All right, welcome back. Okay, so we're going to be starting to work out these scenarios. Scenarios are within each of the storylines. Each storyline will have a number of different scenarios as to the way that storyline could play out, as you'll see in just a little bit here. Together, each of them make up what we call a scenario family, a group of scenarios associated with each storyline. Each individual storyline of the four, there's a number of different ways it could play out, and we call those scenario families, which are each individually made up with scenarios. Let's actually talk about some of the scenarios that the IPCC report is based on. Now, you do actually have to know these by their letter number combinations. For example, the first storyline that we're learning is called A1. A1 is sort of the world as we have it. A1 describes a future world of very rapid economic growth, the kind of thing that we've seen in the last 20 years or something like that. We just say it keeps happening. China. There's a new China. India is the next China. And then maybe, Eastern Europe or South America. We just keep growing and growing the economy very rapidly with a global population that manages to peak in mid-century and then has slight declines afterward. We aren't going to try to keep cramming more and more people onto the planet as different countries become more and more economically developed, their population will stabilize. And there'll be a rapid introduction of new and more efficient technologies, which is both good and bad. On the one hand, we will have an improvement in the efficiencies of cars and so on, but we'll also have improvements in efficiencies of things like how we get fossil fuels out of the ground. All right. It's easiest to see how A1 works when you compare it to A2. A2 is a very heterogeneous world, to use the word that comes to us from climate sciences. When they think about the storyline of A2, climate scientists tell us that the theme here is about self-reliance and the preservation of local identities. A1 is all about globalization. A2 is about we all go our own ways. The economy of China develops in its own competitive way to the economy of Russia, to the economy of India, and we don't really come up with global solutions at all. All these different countries just sort of go their own way. They burn their own fossil fuels as fast as they need to because they're competing with each other. In this kind of scenario, we never get the kinds of economic cooperation to reduce greenhouse gas emissions. We never get the kinds of economic cooperation to find ways to stabilize population and so on. Economic growth is more regional and slower in these kind of scenarios in general compared to the globalization that we have seen in the last, say 20 or 30 years or so. Neither A1 or A2 sound all that great. They also, though, very much sound like our world, okay? The B scenarios, like B1 and B2, are going to sound a whole lot like nicer places to live, although if you scratch a little deeper at some of these scenarios, these aren't such great outcomes either. The storyline B1 describes a world in which the global population does the same sort of thing it does in A1, where it keeps growing until about the year 2050, and then, by then, China and India and so on, their population has stabilized in much the way, say, Western Europe has stabilized at the present time. But there have been rapid changes in the global economy. The global economic system has restructured to be almost entirely based on services and information technology and so on. We are no longer manufacturing billions of doggy toys and Happy Meal toys and every other piece of plastic in China. China has transitioned to being a much greener economy based on services and information technology and so on, as have India and Indonesia and Eastern Europe and so on. All the places that currently have much more manufacturing-based economies, we have used the global economy has found global solutions to shift these economies towards away from manufacturing. The emphasis in B1 is that these are global solutions. When the solution is found, the solution propagates throughout the scenario or the storyline. They are not trade secrets of China that they keep from India. We have global solutions to make global changes to how we burn fossil fuels. Storyline B2 doesn't sound so bad at first. Storyline B2 describes a world in which there's an emphasis on localism, local solutions to sustainability questions, locally solutions to reducing the growth of populations. We have much less economic growth, and the growth that we have is much less rapid and it's more diverse. Wind may turn out to be a better solution in China, but maybe solar turns out to be a better better solution for India, and maybe reducing the power needs of Indonesia might be a better solution, and reducing population growth might happen one way in China versus one way in Indonesia versus another way in India. It's a very regional solution, and doesn't that sound nice? In fact, when you read through the documentation about these scenarios, the B2 solutions often have a lot of emphasis on other ways in which, the economy is based more on local food, and organic and so on, all of which sounds really nice until you dig a little more under the covers and find out that a lot of these scenarios that are set up within the B2 storyline are about things like war. Okay, the global economy isn't that we choose to have a more local economy, the global economy is gone. Okay, or trade disputes and things like that. Not everything in B2 is, the most wonderful of solutions here. Okay, on the other hand, they're realistic. A possibility is the global economy disappears, and we just have regional economies that produce food locally. We don't haul bananas all around the planet because it's not safe to take ships on the high seas to bring bananas across the planet. Well, the good news is that has a lot smaller carbon footprint, okay? This scenario is oriented towards, there's a lot more protection of environment, and there's a lot more social equity and so on, but it all happens locally, it all happens in regional levels and so on, and Africa goes its own way, and Europe goes its own way, and Asia goes its own way, and this is not necessarily a happy scenario, storyline. It might be, but it doesn't have to be. So to kind of pull this all together into diagram as to how this business of scenarios and storylines all work together here, the whole IPCC effort here, the Intergovernmental Panel on Climate Change, their whole effort here is framed around this special report on emission scenarios, where they've defined these different ways to set up the boundary conditions for the numerical models. And within them, they created 4 storylines, A1, A2, B1, and B2. And one of them is basically the world we have now, A1. Booming economic growth, booming population, lots of use of fossil fuels, maybe even more use of fossil fuels than we have now, as we'll see. There are scenarios within this storyline where we burn basically everything. We got A2 that looks a lot like we have now. Growth becomes slower, it becomes more regional, it's less oriented around the global economy that has evolved in the last 20 to 30 years, and becomes more competition between China and Japan, and maybe even military competition between these places. But the growth is a lot like now, when we basically just burn whatever we can find. The B storylines are certainly greener. B is when we have a global economy that has become very much oriented around services and information technology and so on. And when new innovations happen, they spread throughout the marketplace very quickly. So if there is an improvement that it makes solar power more economical, it quickly spreads to India and Egypt and China and Indonesia, and isn't, somehow or other closed off because of conflict or something like that. And then finally, the B2 storylines, which are a very local world with more green solutions, because we don't have the ability anymore to haul petroleum across the planet, or dig coal off the mountains in West Virginia and sell it on the marketplace to Europe or whatever, or haul natural gas from Eastern Europe, from Russia into Eastern Europe or whatever. I mean, we have a greener world in part because we don't haul stuff around the whole planet anymore. So based on these storylines that are crafted, a large number of scenarios were created. In fact, that's what those numbers along the bottom are. So like there will be, let's say, 6 scenarios within the A1B family. You'll see that there's, we break the A1 family up into 3 pieces. But like the A2 storyline gets broken up into 4 plus 2 equals 6 scenarios, where we have slightly different, what if we're in an A2 scenario, but the price of oil falls to this? Or what if we're in this A2 scenario, but it becomes this cost-effective to extract oil from from tar sands, and so on. So there's scenarios within each of these storylines that we can investigate, and all of them have been thoroughly investigated by sociologists, engineers, climate scientists, economists, and so on, to come up with big tables. I don't think you can probably read this on the YouTube video itself, but if you print the handout or whatever, you can get it, or you can get this from the IPCC report, where, like, you know, at every place along the way, like we've got the A1 scenarios there. What are the carbon dioxide emissions at in terms of gigatons of carbon per year at all these different years? This is just a summary of it, so it just has it for like a few places, like 2020, 2050, and 2100. What are the sulfur dioxide emissions? What are the methane emissions? What is the world population? What is the world's use of electricity? How much of the mix of power comes from renewable sources? How much? All these things have been gamed out for each of these storylines and all of the scenarios within the storylines. What if this was too optimistic of an idea of how much of our power could come from renewable sources, etc.? And so we actually can group some of these scenarios together within the A1 family into what we call scenario groups, actually, where like A1 is actually broken up into 3 groups. That's actually, I believe, the main one that gets broken up like that. Let's actually take a look at these possibilities here. Here's A1. This is the one that's most like the world we live in now. And actually, if we look, these are the carbon dioxide emissions in terms of gigatons of carbon per year over the next 100 years until the end of the 21st century. And you can see that there is a main scenario. There's 3 main scenarios here. And within them, there's actually, these are the 3 main scenario groups. And then within them, there's a little bit of range as to, like, you know, each of the possible scenarios has a certain range of outcomes here. The first one is the A1FI for fossil intensive. This is a group of scenarios that we use that certainly sounds like our world, where we just keep finding more and more fossil fuels to exploit. The price of fossil fuels stays in a range where it doesn't get so expensive we don't use them anymore, and yet it's profitable enough that the oil companies keep finding ways to frack someplace they haven't fracked yet, or extract oil from tar sands that they haven't done yet. And that seems to be how the world is progressing. Okay, if we look at the history of the last 20 years, it looks a lot like the A1FI set of scenarios in which we just keep finding more and more fossil fuels. Okay, they never get so expensive that we can't do it, and they never get so cheap that it isn't worth looking for them anymore. And you can see, I mean, if at the present time we're emitting about 9 gigatons of carbon per year, you can see it gets to be pretty bad. By the year 2100 in the A1FI's carbon emission scenarios, we get up to 35 gigatons per carbon per year. That is, you know, what, like, we can't do the math right now, like more than 3 times as much as we're emitting right now. Holy smokes, that's a whole lot of carbon dioxide getting emitted in the Earth's atmosphere in those scenarios. You can see that there's a set of scenarios that are labeled A1B. A1B is the set of scenarios that are sometimes referred to as the business as usual scenarios. This is the ones that kind of assume that there's such a thing as peak oil and peak coal and so on, where after a while, it's just not economical to find anymore, okay? Coal is too expensive. After a while, you know, the harder and harder it gets to extract oil from tar sands or from fracking or whatever, you can't afford to buy it anymore. Okay, we hit peak oil and we hit peak coal and peak gas and so on, where eventually the only sources left are just too expensive to extract, and we're kind of forced to start burning less fossil fuels. It can be a number of different ways, either through greener technologies or whatever, but in terms of our carbon footprint, it doesn't particularly matter. We hit a peak of fossil fuels. But don't get me wrong, that peak is not a happy place. We're already unhappy with the way climate changes we're observing when we're emitting 9 gigatons of carbon per year. And as you can see, the A1B scenarios, the business as usual scenarios, you know, they peak, you know, around, I don't know, the mean of them is about 17 or 18 gigatons of carbon per year. And some of them are well north of 20 gigatons of carbon per year before carbon emissions start going down. Oh man, these are not happy scenarios. A1 is not so good. Even A1T, which is the group of scenarios based on economic growth where we phase out carbon intensive technologies like fossil fuels and so on, and start replacing them with greener technologies like wind and solar and tide and geothermal and nuclear and so on. Gosh, if I look at those A1T scenarios, well heck, all of them look still better than what we saw before, but still not so great. I mean, even with this quite rosy mix of power as we try to phase out carbon-intensive technologies here, it takes about 100 years just to get back to the carbon dioxide emissions of now. All that time we've been emitting more. We've not done anything to remove carbon dioxide. Oh my goodness, by the time you get to the year 2100 in these A1T scenarios, This is our best bet so far that we've seen, and still the carbon dioxide concentrations are going to be way higher than they are now. We've finally, by like the year 2080, gotten to emissions that are at the same as about 1990s emissions. And that's if we spend enormous amounts of energy, effort on solar and wind and nuclear and so on. All of these A1 scenarios look pretty alarming. All of them involve emitting a heck of a lot more carbon before things get better, if it ever gets better. Well, I mean, in terms of how much emission. All of them sound, frankly, pretty plausible. Okay, I don't know that I think it's all that unlikely that we're just going to keep finding more and more fossil fuels, and we're going to find technologies to get fossil fuels out of more and more nooks and crannies of the earth. Those scenarios look bad. A2 doesn't look so good either. Remember, A2, these are the scenarios in which the population just keeps growing and growing. We have a much more local world where there's less cooperation, there's less international planning as to agreements to get rid of fossil fuels. We just have more and more competition to have more economic growth between China and Japan and Russia and the Middle East and Africa and South America and all the emerging economies, and we just have more and more growth. And don't get me wrong, not necessarily peaceful growth. Some of these scenarios within the A2 family are pretty unhappy, but all of them involve growing. There are no ways to have the total amount of carbon dioxide being emitted each year to go down in those kinds of scenarios. No matter what, carbon dioxide emissions go up, and if the emissions are going up, there's no hope for the amount of concentration of carbon dioxide in the atmosphere. That's going to keep going up and up. Let's find something happier. How about B1? Now, the B1 scenarios look better. They're in some ways the Star Trek solution here, okay? Not as in we're traveling to other planets, but the idea that the world gets better and better at having global solutions to problems. There's more cooperation, there's more work on population, overpopulation, there's more work on sustainability, there's more work, and we just keep finding greener solutions and so on. They look better. They are about an economy that globally makes a transition to being more about information services, more about service economy, etc. But notice it takes, even under these very rosy, I mean, B1 sounds like a world I want to live in, but even then, it takes a long time before the emissions start reaching the same as what they are in 1990 or current levels or whatever you want to say. I mean, it's not probably going to happen in my lifetime, even if there are these really, really very liberal, for lack of to use a word somewhat loosely here, some very green assumptions. Even then, it takes a really long time before emissions are as small as they are now, and we don't like the emissions now. And we'll have been emitting more, and this is not such a great situation either. This is not so happy. Now, B2 sounded okay. B2 was the one where we go for local solutions. We're not hauling stuff all around the planet anymore, whether that's plastic toys from China or fossil fuels or whatever, or produce that's out of season and we carry it from one hemisphere to another. We are getting more local solutions. We're getting, admittedly, more equity, emphasis on sustainability because regional economies have to be sustainable. Okay? On a global economy, you can kind of hide the fact that it's not sustainable because it can push it off on somebody else. If your economy is more local, you got to make it more sustainable. But look, it doesn't work. When you actually work in a scientific, interdisciplinary way on these local solutions, they don't really work. Now, the reasons why are kind of technical and beyond the scope of this class. I mean, we're not trying to go diving into social policies and stuff like that. But it turns out you just can't fix your problems of global change in this way, because individual local areas like the Middle East or southern South America or something like that, or northern Europe, individual areas are not going to find a replacement that's cost effective for something like automobiles. Okay, that's going to take a global effort, and when a solution is found, we need to propagate it everywhere. A small region just is not going to solve all these problems. It's going to be cheaper for them to just keep using the old solutions, like automobiles, okay, or coal-based power, okay. South America is not going to invest in reinventing nuclear power, okay. Given a choice, if they're cut off from the rest of the world in a B2 type scenario here, they're just going to burn coal, okay. There's coal in Argentina, they'll just burn it. Okay? These scenarios are not great, and notice that none of them are saving the world. I don't like any of these, okay? And it's bad news. In fact, if we take a look here, this is a graph that shows from 1900 until the year 2100 here. They're going to have the amount of fossil fuels being burned each year, the global carbon dioxide emissions here. And what they've done is they've just made it so that they've changed the units here so that 1990 is 1. 1990 is the unit, and then if we double it, we're at 2, and if we triple it, we're at 3, and so on. So I just drew a little line from 1990 across to the year 2100, and if you look at all the individual scenarios, I mean, there's, 3 dozen or something individual scenarios here that the IPCC has studied out. If I actually look close there, only a couple of the very most optimistic A1T and B1 scenarios ever get the solutions back to 1990 levels. Remember, A1T is the one in which we really invest in green technologies, wind and solar and nuclear and tide and geothermal. Even, within the A1Ts, only a couple of them manage to ever get below 1990 levels. And only a couple of the B1s, that's the kind of Star Trek solution where we have global government, global and intergovernmental efforts to make the greenest possible transitions in the economy. Even a few of them only ever managed to get as good as 1990. I'm not happy about that. In fact, if you take them, keeping in mind, all those graphs, that's just the amount being emitted. None of that is about how much we've added altogether. So if you actually switch to a graph that shows the total emissions over time, heavens, they're all a disaster. I mean, yes, the B1 scenarios, which are the green ones there, they have less total emissions over the rest of the century than, say, the A1FI, the fossil-intensive ones. But they're all terrible. They all involve vast increases in the amount of carbon dioxide in the Earth that we're adding to the Earth's atmosphere. The people who don't want to make changes aren't entirely wrong. I mean, even the ones in which we spend trillions on new technologies and sustainability and so on, we still end up with some pretty dire outcomes. In fact, if you actually switch that, the units of that were kind of difficult. That was in gigatons of carbon total emitted. If we just switch that to what the projection means in terms of what the concentration of the atmosphere, the atmospheric values of carbon dioxide are over the next 100 years or whatever. All right, so I drew a red line on that diagram there at 260 parts per million. That is the pre-industrial level. In all of these different scenarios, A1, A1T, A1FI, A2, all of them are shown on there. None of them ever even come close to pre-industrial, right? In fact, our current concentrations, which are around 400, none of them. I mean, our current values are horrible, and we're never going to see them again. Even in the most optimistic scenarios, like B1, we're never going to see 400 parts per million. We are headed north of 400 parts per million, and it is never coming back in any of these scenarios, no matter how much money we spend. Uh-oh. This is serious. This is a serious problem. Often in climate science, we talk about doubling the carbon dioxide. That used to be kind of the threshold that people were concerned about. What happens if we double the carbon dioxide from its pre-industrial level? That's 520 parts per million. Yeah, guess what? We're going to do that. It used to be if we doubled the carbon dioxide. Oh, no. With the growth of the economies of developing economies of China, India, Indonesia, and so on, it's a done deal. It's going to happen. We are going to double carbon dioxide. It's going to hit about 520 parts per million. It's going to happen sometime between 2040 and 2060, depending on which of these paths we're on, which emission scenario turns out to be closest to the real world. But all of them, even the most sunshiny, rosy, green solution ever, we are going to double carbon dioxide. We can't stop that. Oh no. It's just when does it happen? 2060, 2040? Uh-oh. All right? Well, we could double. What about the current carbon dioxide of being 400? What if we doubled that? Will that ever happen? Well, I drew the line up there at 800, and yeah. Both A1 and A2 managed to double the current 2016 concentrations. And A1 and A2 were the two that sounded most likely. That sounded like our world. I'm not sure I buy that we're going to come up with some kind of global structures to switch the economies of the world over to service and information based the way we would need to in B1. A1 and A2 sound like what's going to happen, and that's bad news. We're punching right through double the current carbon dioxide. Oh, shoot. Remember those climate change negotiations that happened in Paris in the fall of 2015? They came to the conclusion that in order to minimize the amount of damage to the world economy and the world environment and so on, and to promote sustainability, we needed to keep the total global climate change under 2 degrees Celsius. And in order to do that, their estimate was that we had to keep the concentrations of carbon dioxide under 450 parts per million. So I drew 450 on there as that red line. Yeah, good luck with that. It is extremely difficult to see how anything could make that happen. Even the most ambitious spend trillions on green technologies type scenarios don't even come close to stopping before they hit 450 parts per million. This is dark stuff. This is not looking good at all. I mean, none of these scenarios are really saving the world. It's just a matter of how bad it gets in terms of greenhouse gases and so on. Don't get me wrong, we have a lot of control of how bad things get, but it's bad. Remember, what we're trying to do here is we're trying to get some, we're going to try to create an ensemble of numerical models of climate, and in order to do that, we want them to have a wide range of boundary conditions. And so what the IPCC does is they've created these scenarios within these different storylines. And for each of the, roughly 36 scenarios that are a part of this here, they have specified this year, this is the amount of carbon dioxide that would be in the atmosphere, this is the amount of methane, and then they have lots of other things too, albedo of the Earth, and all kinds of factors that are the boundary conditions to the model. So every team of scientists that runs a global climate model around the world, they've got access to a supercomputer and they're running these models. They download the exact amount of concentrations associated with, the greenhouse gases associated with each of the scenarios, and then they run their climate model using this information as the boundary condition. And this is so smart. This is such a good strategy. The IPCC is really just amazing. No wonder they won the Nobel Prize. What happens is, when we use a strategy like this, we actually come up with not just one, but 2 different kinds of climate change model ensembles. See, for each individual model, we now have we have an ensemble of different simulations using slightly different boundary conditions. If I'm talking about the ECMWF model, the names aren't all that important. That's the European Center for Medium Range Weather Forecasting, and they have a climate model. If I'm working at the ECMWF and I've run it for all 36 of these scenarios here, I kind of have an ensemble now, right? I can see, if 2 different scenarios within B1 resulted in wildly different climate forecasts, that makes me worried. I mean, I can ask myself, as I look across all the output of my models from all these 36 different runs, what is the range of outcomes for global climate? If they're all scattered or are they all very similar? Does this give me more confidence in my model? Does this help me identify where there might be a problem with my model? Isn't that smart? I mean, each group now has a set of model output that is like an ensemble for what does that model say, or what does the model out of Colorado say, or what does the model out of Princeton say, or whatever. Brilliant. Okay? Plus, for each of these IPCC scenarios, like, A1B and then, the scenario 5 within there or something like that, we now have an ensemble of different solutions using different models. For that particular scenario, we now have what the group in Hamburg say, what the group in London say, what the group in Colorado say, what the group at Princeton says, and, about a dozen others. Isn't that smart? That's another type of ensemble. If they're all saying the same thing will happen, that gives us a lot of confidence that that's probably what's going to happen. If they give us a range of solutions, that tells us something about how certain we are. This is actually brilliant. Man, that IPCC is great. They do just great science. They really do, well, they don't do the science. They're the ones kind of coordinating how this works and how to interpret it for policymakers and so on. All right. So now we see how they're going to do this. So based on all of this, what do the different global warming models, climate models tell us about global warming under all these scenarios? We're saving that for another module. It's not going to be pretty. The question is, how bad is bad and what can we do about it? All right. Great. Let's finish up this lecture with 3 quick questions. Number 1. Oh, and the reason why I'm asking you these questions, I want to give you a sense. You do need to know A1, A2, B1, B2 in terms of what's the broad outlines. Let's just give you a couple questions as examples of that. In the A1 scenarios, mankind, A, establishes a global green economy. B, burns fossil fuels as long as it is economically viable. C, reduces carbon dioxide concentrations in the atmosphere to pre-industrial levels. Or D, reduces carbon dioxide emissions to 1990 levels in 50 years. What exactly is the A1 scenario telling us? All right, look through those 4, think about it, follow a link and get some feedback before we move on to question 4.